welcome back to my channel. My name is Rakshit Subramanya, studying in SVCE, and today I am going to be doing a presentation on the topics additional list operations, sparse matrices, and doubly linked list. So first of all, let's know what is a linked list. What is a list? A list is a data type that is capable of storing multiple elements in an ordered format. It provides some of the key characteristics which help the programmers to alternate data and such. The characteristics being ordered collection, which means the elements maintain the occurrence in which they are inserted, or in short words, the elements maintain the order in which they are inserted. So the first element which is inserted is going to be in the same place and it won't be changed. The next element will be the next one. So it is done according to an index operation, which you'll see soon now. So duplicates are allowed in lists, which means multiple elements of the same can be there in a list without causing any problem. Index based, which I mentioned just now, where each and every block in a list is given a number ranging from 0 to n depending upon the size of the list. So accordingly the elements are under the same index and they don't change their places unless we change them. Next is the interface. So list is an interface defining the available options but not providing concrete implementations. There are additional list operations which help in these implementations, which we'll be seeing soon now. So let's move on. So introduction to additional list operations. So here we come into the first concept. Additional list operations refer to the various functions that can be performed on a list beyond the basic operations like insertion and deletion. The operations provide more flexibility and functionality to the programmer to manipulate and access the data within a list. Some common additional operations include searching, sorting, merging, and reversing. So the additional list operations have made the programming concept very easy since they help a programmer to mold the list according to their wish. So let's move on. So the different operations being traverse, where we can access the each and every element of the list at least once. Insertion, where it adds a new element to the list. Deletion, where it removes an existing element. Search, where you find an element in the list. Or sort, where you sort the elements according to ascending or descending order. So let's now know what is a linked list. A linked list is a data structure that contains a linear collection of data elements. Unlike lists, here there is no block representation. In list, all the blocks are connected, unlike this here. In linked list, the blocks are divided into two types. One being the data type, where the data is stored, and the other one being a pointer. So the data block stores the data while the pointer block points to the next node. So it is called nodes in linked list. But in normal lists there is no pointers, but it's just a few amount of blocks connected to each other for representation. Let's move on. Now, since we know linked list, let's talk about doubly linked list. A doubly linked list is a data structure that consists of nodes with two pointers, one pointing to the previous node and the other pointing to the next node. So here you can see instead of one pointer there are two pointers, one pointing to the next one and the other pointing to the previous one. The bidirectional linkage allows for the traversal in both directions, enhancing flexibility in the list manipulation. Doubly linked lists are used when frequent backward traversal or insertion or deletion at both ends is required. The doubling linked list is mostly used when there are multiple insertions and deletions that take place across a given linked list. So let's go to the next concept, traversing a linked list. So here, displaying the content of a linked list is very simple. We keep moving from the temp node to the next one and display its contents. When the temp is null, we know that we have reached the end of the linked list. So we get out of the loop. So here is a program that will help you to understand what happens in a linked list. Please do try executing this once. Next, inserting an elements into a linked list. In a linked list, you can add the elements either in the beginning or in the middle or the end. So let's see in insertion at the beginning first. With insertion at beginning, we can allocate the memory, store data, change the next of the new node to point towards the next one. So while creating at the beginning, you can create a node which is pointing to null, and you can make it point to a different node. So you have the control over it to point it to the next one. So here is a program which will help you with that. Now let's move on. Inserting at the end. While inserting at the end, the memory is allocated for a new node. Again, like the previous one, then there is a new node allocated and the data is stored. So now we traverse to the last node and we change the last node. We don't add a new node and point it to the head node. We change it. The last node which is pointing to the null will be pointing to the new node we created, and this new node's pointer will be pointing to the null again. So this way we are inserting an element in at the end. So here is another program that is going to help you with understanding insertion at the end. Now let's see the middle one. So here we allow again, once again, like the previous two one, we allocate the memory and create a new node. And now we traverse to the node before the required position. So where the node needs to be, element needs to be inserted, we go there. We delink the nodes which are connected and make sure that our new node is pointing to the next node, while the next node is pointing backwards to us also. Like I said, doubly linked list will point forward also, backward also. So we make sure our new node is pointing to the next node while the next node is pointing back to us. Same wise to the other side, where we make sure that our new node is pointing backwards to the previous node while the previous node is pointing to our node as the next one. So here is another program that will help you understand this concept. Now let's see deleting from a linked list. You can delete again, like how inserting happens, you can delete from the beginning or the end or from a particular position. So deleting takes in a different place in linked list. Unlike deleting the element, we have a reference. You can keep one reference, and if you say delete this reference, it is going to delete everything. You'll understand. Let's say the form. So deleting from the beginning, the head that is pointing to the next one, if you just delink it, like how I said, you can just use that reference. So if you just delink that reference and make sure it doesn't point to the next node, you have deleted it. That node doesn't exist anymore. While deleting from the end, you traverse to the second last element and make sure that second last element points towards null. So the last element is deleted. Here you can see a program which will help you in understanding that. Now deleting from the middle. To first we traverse to the element which should be deleted and the element previous to it. We make sure that it points to the next element which it after deletion, after the element that needs to be deleted there is another one, right? We make sure it points to that one. It doesn't point to the node which needs to be deleted. In that way we delete the nodes from between also. So here is another program that will help you understand that. Now searching elements in a linked list. You can search an element in a linked list using the looping statements. So first we make a head or the current node where we are at as the head node. We run the loop until the current node is null because the last element points to null. So we see every element in that way. Since the last element points to null, you're going to traverse through every element in the given linked list. While in each iteration we make sure to check that is it the required data. If it is our required data we can take it, or else the element does not exist. So here is another program that will help you understand that point. Let's move on. Sorting elements of a linked list. There are multiple ways of sorting a linked list, and now we'll be seeing one called bubble sort, which will be used to sort a linked list in ascending order. So we'll explain this with the help of an algorithm. So here first we make the current node or the head node or the primary node, the first node, and we check if the head node is null. If it is null means there's nothing in the linked list and it is totally empty, and we return that the linked list is empty. Else we run a loop until the last node. So you again traverse toward the node till the end. While traversing in each iteration, we follow that the next node is told. We compare the two nodes, the next node and our current node. If the next node is greater or smaller, we swap them. So depending on how you need it, you swap them, either ascending or descending. So based on your condition it will get swapped, and that way you can sort your linked list. So let's move on. So here is a program that will help you understand how the sorting takes place. Please do pause the video and see the program once. Let's move on. Sparse matrices. So a sparse matrices or a sparse matrix is a special case of a matrix where over 2/3 of the matrix is zeros and only few parts of the matrix is going to be either one or basically a non-zero element. So sparse matrices are commonly encountered in various domains such as graph theory, image processing, etc. Now storing and manipulating a sparse matrices efficiently requires specialized data structures and algorithms, which you'll see now. So this is a sparse matrix. As you can see, most of the elements in the matrix are zero, while only few of them being a non-zero element. So now the sparse matrix representation can be done in two ways. The first way being using arrays and the second way being using linked list. So here you can see the array representation, which is the first method. So a 2D array is used to represent the sparse matrix in which the rows name and the column's name are mentioned. The rows index and the columns index and the values are mentioned. So if you can see the box here, the rows says 0. So meaning the first row 0, the topmost is the index 0. And as you saw in the previous one, the first row is 0, index 0. So in the first row, column 2, so 0 1 2. The second column again vertically 0 1 2, that is going to be the indexing with 0 1 2, and as you can see there is the value 3 and the value is 3 here. You can read the table vertically. So again it is row is telling 0 in the second one, so it is in the topmost row only. Column is saying 4, so vertical wise if you count 0 1 2 3 4, as you can see in the fourth column it says the value is 4. So it is there in the sparse matrix. This way the sparse matrix is represented in arrays. You can try for the rest of the elements, you can match them, you will see it. So now let's see the second method. So in the second method we are going to be using the linked list. So here we use the rows index, columns index, value index, and one thing extra is a pointer which points to the next node. So let's see here. As you can see, it is a linked list representation. Here there are two blocks, one block having the data and the other block pointing to the next one. The data block is split into three. The first being the row, the column and the value. So again, as you can see in the first node here, 0 2 3, 0 is going to be the row which is the topmost here, 2 is going to be the second column as you did the indexing in the previous one, so 0 1 2, and the value there is 3. Just like that it has been done for other elements, you can go through once. Let's go to the next one. Doubly linked list. A doubly linked list is represented using a linear array. Arrays in memory where each memory address stores the three components. So this is it is not exactly like this. To explain, I tried to tell this. So if you take it in form of a array, as you can see, there will be three blocks: the first block, the middle block and the last block. So for the sake of explanation I have mentioned as an array. So as you can see in the starting, the previous first block which is the pointer and the last block which is a pointer, the first block is pointing towards null in the first node. It is pointing towards null because it points to the previous one. But the next one is pointing to 100, which is the address of the next node, while the data being stored there is 2. So in the form of array I'm telling, but it is actually in a linked list. It is stored as a linked list. Let's move on. Advantages of doubly linked list over singly linked list. A doubly linked list or DLL can be traversed in both directions, forward and backward. The deletion operation in doubly linked list is more efficient if a pointer to the node to be deleted is given. So it has multiple pointers pointing to both sides, so it's even more efficient to delete the elements. So we can insert a new node before a given node. So here it allows you to traverse backwards, so you can insert more elements even backwards. Now some of the disadvantages. Okay, one. In a singly linked list, to delete a node, a pointer to the previous node is needed, while in doubly linked list it is present. So as I mentioned just now, since it points backwards also, you can delete backwards also. But there are some disadvantages, being Every node of the doubly linked list requires extra space for a previous pointer, while singly linked list needs only one space for one pointer. And another one, all operations are require an extra pointer to the previous to be maintained. So not just one node, but every node will require one previous pointer which will be pointing towards the back one, which takes a lot of memory. So it takes a lot of space. Now, applications of doubly linked list. It is used by web browsers for backward and forward navigation of web pages. It is used for the least recently used and most recently used cache constructions that happen again in your web browsers. It is used by various applications to maintain undo and redo facilities, such as your Microsoft PowerPoint. You have such methods where you can undo and redo. So these use linked list for such operations. Now, next one. So this is the representation of doubly linked list as I showed before. Now I'm showing it as a form of a linked list. There's a program which is the syntax for it, and you can see previous is the backward direction and the next is the forward direction. A is the data stored, and there are the 2 pointers. Thank you. Hope you understood something from my video.